This is an impromptu video of me showing GPT-3 and how it can be used in cybersecurity. So, since I haven't been talking about GPT-3 yet on my YouTube channel, and I assume that I'm gonna be talking a lot about it in the future, I just want to give a brief introduction, like a 3-4 sentence introduction of GPT-3, because if you're interested in it, you'll probably just Google it and see what it's all about. So GPT-3 stands for Generative Pre-trained Transformer. 3 is the current version of it. And this actually means it's a machine learning or artificial intelligence transformer model, which is a type of very beautiful architecture of machine learning. And this is actually a type of model oriented towards natural language processing. So GPT-3 has been trained on the entire internet plus a couple hundred thousands of books. So it knows a lot, and right now it has 175 billion parameters. So it's billion with a B, which is a lot, and this means that the model knows a lot and you can extract information from it. Well, since it knows a lot since it's been trained on the entire internet. And you can extract information from it by actually knowing how to query it appropriately, how to prompt it appropriately. This is a few-shot learner or a few-shot learning model, meaning that since it knows a lot, you actually have to give it a few examples to kind of have it focus on the topic of what you want. Because if you just start like writing, for example, the meaning of life is, the model is going to fill in with the text that is with the words that are most appropriate in that specific context. So for example, if you want to get factual stuff from GPT-3 like real world data, you would have to prompt it like with real world examples. So you could say that the US president in the year 1947 was, and then and then you actually fill out with the real name of the president. Then you give GPT-3 a couple of more factual data, and then it'll actually know how to respond when you actually query it something from the real world. It's very much easier to actually have it generate fiction and like art. For example, verbal art. It's much easier because it doesn't have to, you don't actually have to prompt it with a very neatly engineered prompt. So what I want to say is that I think in the future, one of the jobs, not only in the future, but also in the present moment, because I see a lot of requests for this, is prompt engineering. And by prompt, I'm actually saying what are you querying the model, or how are you querying the model to get the exact type of information you want. So in here, what I'm dealing with is a combination of AI, machine learning. So basically AI is part of machine learning. So I like not to talk about AI because it's a heavy word. Let me just talk about machine learning, which is like more scientific. So this is a combination of machine learning and cybersecurity. And I just want to showcase, first off, this is a mobile application that I just created and published like yesterday, so it's on the Play Store. This is basically a wrapper on the GPT-3 API. So GPT-3 is a creation of OpenAI, and you do not have access to the API unless you have been granted permission via a request that anyone can do on their website. For example, I have waited months after I submitted my request to actually get access. Now what I've done here is I've built an Android application as a wrapper on the API and the playground. So this is like the first iteration of the application, and over here this is where you input your API key. So this is like the application has no functionality unless you have the API key. And now my API key is on my clipboard, so I'm just going to paste it and use it, and boom, it's going to be used in all the requests that are done to the API. Now I'm not actually going to go into the details of the API, but what I want to say is that I've created two prompts or two queries for that are specific to cybersecurity. So for example, let me show you what this is capable of. Let's actually start with some sort of a fiction. And you can see we have, and that's not actually cybersecurity. You can see we have a few parameters over here. We have temperature, which makes the model less or more deterministic. For example, deterministic means less or more random when it comes to the type of next token that is being given to you. Token by token, you can think of a word, which is not exactly accurate, but for simplicity, a token is a word. In this case, we have the max token field, which we can set to 200, for example. We can have the temperature higher. Let's say we want to generate fiction. So with a higher temperature, this is going to let the model pick more random words. So this is good for fiction. Top P is another parameter that controls the output in terms of determination and randomness. So you wanna experiment with either toggling the top P or the temperature. So in this case, we'll just leave the top P as it is. And we have the engines, in this case, from the cheapest to the most expensive. The cheapest is also the fastest, the Ada. Then you have the Babbage and Curie. Curie Instruct Beta, the Instruct versions of Curie and Da Vinci are like very new models, and they actually sort of require zero-shot learning. They better understand your prompt. Okay, now for our purposes, we're going to focus on the two most expensive, which are Da Vinci and Da Vinci Instruct Beta. And we'll start with Da Vinci. And for example, let me give it a prompt, sort of like, let's say, one thing many people realize later in life is, and then let's say not 200 tokens, let's say 150 tokens. We have Da Vinci, we have the temperature, and then we get that the only constant in life is change. The way you look at your health may change as you move further up the life experience curve. That's an interesting way to put it. And you can find yourself shifting from one kind of diet to another. You may start out eating like a vegetarian, but eventually make it all the way to where you are now. Finally and proudly donning the title of meat eater. My own personal journey, so it comes to coming up with stuff. If we set the model to being less deterministic by toggling the temperature to, let's say 0.3, we'll do the get. So this is going to make the model pick less random tokens. So one thing many people realize later in life is that they are not the person they thought they were. They have been living a lie That's not good. And it is only when they start to look at their lives that they realize this. It is very easy to live a lie in your society. We are bombarded with messages telling us what we should do, how we should act. Okay, so I should probably start another YouTube channel for this kind of prompt. Now, two prompts that I've just developed for cybersecurity are this one. So first, for penetration testers, here is a list of 10 valid web application file paths that contain what do they contain? They contain security, not security trails, but security misconfigurations and sensitive information leaks. Okay, let's actually start with the temperature of 0.5. So the temperature is between 0 and 1. We have the max tokens. Let's set it to 200. Now for DaVinci, the price for 1,000 tokens is 6 cents. And DaVinci, as I said, is the most expensive one. For example, if DaVinci for 1,000 tokens, which is roughly 750 words generated, for DaVinci that's 6 cents. For Curie, that's 10 times as cheaper. So I don't even know what's 6 cents over 10. It's like half a cent, right? Yeah, so it's like 0.6 cents, which is quite cheap. Now, we'll start with the DaVinci because it's the most powerful and most accurate. And we should be good to go. Temperature 0.5. Let's see what we get. And don't use this in your word lists when you fuzz. So we have uploads, WP content. For example, if a web application is vulnerable to path reversal, and then it goes on and on. So we have the temperature set to 0.5, and in this case we might get some really good results. We don't even need 200 tokens if we just request. So look at it like this. The model is actually, when I say for penetration testers, it actually focuses on the cluster of words that are associated with penetration testers that has been associated with penetration testers in its learning process. So it's been trained on the entire internet plus a couple of 100,000 of books, and it clusters similar words to one another. So it would very likely cluster penetration tester with cybersecurity, with bug bounty hunting, closer to one another than it would cluster penetration tester with flowers and trees and croissants, for example. And this is how it actually generates the next word. So it's mind-boggling how it knows what file path means, how security configuration, what security misconfiguration means, and it actually understands my entire context, and it gives me exactly the kind of information of what I want. Now, if I'm controlling for the temperature, if I set the temperature higher, in this case, it would probably come up with bogus, non-existent file paths. Like, for example, let's say 0.9. And this is going to increase the randomness. So as you can see, it's not like exactly what I want. If we put it like to 0.009, so let's say, or 0.1, the model is going to be more repetitive. Or not, but still it's going to give me like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's given me exactly the number of paths that I asked. So this is mind-boggling. This is I don't know. I don't even have words to describe this. Now let me actually focus, because this video gets longer and I don't want to spend too much time on it. Let's actually go through the second prompt. The second prompt: modern web application misconfiguration, not misconduct, but misconfigurations, of course. And so as you can tell, two of my favorite types of vulnerabilities are looking for misconfigurations and sensitive data exposure, and of course business logic flaws. So this is what I'm mostly focusing on when I test networks, mobile apps, and web apps, which I hate the most. Modern web application misconfigurations are sensitive and sensitive data exposure. Let's say a pentester perspective. Modern web application misconfigurations and sensitive data exposure. A pentester perspective in, let's be very specific, 150 words. Dot. Now, let's do the Da Vinci model. Let's have the temperature 0.1 is okay, so the model is going to give us less random, more sort of like accurate values, and should be good to go. Let's have 200 tokens, because when it comes to calculating the output, max tokens is for the output. When it calculates the output tokens, it actually calculates the input plus the output. So in this case, if we want 150 words, I would assume that my prompt here is in the vicinity of less than 50 words. Okay, let's do the get. See what it comes up with. I'm assuming, and I hope the model assumes, that I've given it a title. The web application is the most common attack vector for hackers. It is also the most common way to expose sensitive data. Now notice the extremely stellar, grammatically correct way of outputting the data. You cannot tell whether or not this is a human being, an expert in cybersecurity, or it's just a machine learning algorithm. So I could actually take this entire output and post it on my website and say, hey, look how smart I am when I'm a dumbass. In this article, I will try to explain how a hacker can exploit a misconfiguration in a web application and how we can use it to gain access to sensitive data. The first step is to find an interesting target. The hacker will use search engines like Google or Bing, and it also knows about Shodan Senses and Zoomeye. Is Zoomeye really a thing? He will look for websites that are vulnerable and have interesting content. He will then scan the website with tools like Acunetics and Web Vulnerability Scanner or Burp Suite Intruder. Interesting. So it knows stuff about Intruder. These tools are able to detect vulnerabilities in web application and allow him to exploit them if they exist. So we've set the temperature very low, the model is less random. What if we do a higher temperature like 0. 0.7, for example? Let's see what it comes up with. In the first part of this series, I covered web application vulnerabilities. In this part, I will cover web application misconfigurations and sensitive data exposure. To begin with, when I'm testing a web application and accidentally find a sensitive data exposure, I'm always wondering about how it is possible for the company to make such an error. Is it a misconfiguration or have they made an error while developing? Let's start with some definitions. A misconfiguration is an instance in which a computer system network has been configured incorrectly contrary to its intended configuration or misuse. Wow, so I I I have no freaking words. I seriously have no freaking words. Now, this is not artificial intelligence. This is like machine learning on steroids. A language model, if you understand or if you grasp how a language model works, you understand that this is actually an algorithm that knows a lot of things, and if you prompt it in an intelligent way, you can get whatever you want out of it. It has no meaning. It doesn't understand what it knows, but this doesn't prevent you from getting extremely insightful information out of it. You might not get the exact accurate answers you want, but the model can give you leads. So for example, if you're searching for something, it knows the entire internet. It has been trained with a few data sets that comprise of those data sets are curated versions of the web. It's called Common Crawl, and their date is 2019, but I don't want to go into the entire discussion of it. What I want to point out is that this is like next level stuff. So I'm only curious what would happen when GPT-3 or other models are trained with more parameters, and Google has just said or announced in a paper earlier this year about the switch transformer, which is another transformer model similar to GPT-3, whereas GPT-3 has 175 billion parameters. The switch transformer by Google has 1.3 trillion parameters, so it's like an order of magnitude bigger. And what would happen if you give that model a higher quality of data to train on compared to GPT-3? It's like the apocalypse is gonna come, or I don't know. It's like maybe that type of model is going to, if the architecture is gonna be different, that type of model is going to give a whole nother level of meaning to the entire world. But anyway, I don't want to fantasize here. I'm just showing a few ways in which you can leverage recent developments in machine learning and artificial intelligence, which is a word that I hate, in cybersecurity. And in this case, you could say modern web application misconfigurations and sensitive data exposure, a pen tester perspectives in 100 words with a humorous twist. That way you can make it even entertaining. I don't think this is humorous, but anyway, by the end of this course, you will have all the skills required in order to call yourself an ethical hacker. If you don't feel comfortable with it yet, please go check our free section on penetration testing first. We're going to attack a vulnerable VM. Okay, so this is fabulation. Let's set the temperature to point, let's say point sort of like close to 3. The story, an application is running on a server. The server is accessible from the internet. He now has access to all of the sensitive data. He can use this data for his own goal or sell it to someone else. This is bad news with the company that owns this data. They will probably lose customers, money, and reputation being taken against them by the customer. So what went wrong here? Why was there a breach? So no humor so far, but maybe if we would have let the algorithm keep on generating, like maybe let's say 500 tokens, we would get our humorous twist. Or maybe I have to design this with a humor twist in another way so that the model gives me what I want. But in any case, this is how you combine for your own good, how you can combine for your own good and for the good of others, recent developments in machine learning with cybersecurity. Signing off.